Well, hello Internet, and welcome to part 14 of my C++ tutorial series. In this part of the tutorial, I'm going to cover a whole bunch of things I've received questions on. I'm going to show you how to include outside files, how to use preprocessor directives, templates, iterators, and a whole lot more. Like always, all the code is available in the description underneath the video, and if you haven't watched any of the previous parts of this tutorial series, you should, and I provide a link to the beginning of this tutorial series above, and I have a lot to do, so let's get into it. Alright, so here we are inside of NetBeans once again. Of course, you can use any ID. Alright, so basically what I want to talk about here first is you're going to want to include this iterator library right here because we're going to be talking about iterators. But specifically what I want to talk about is this hash symbol right here. Now anything that starts with a hash symbol is a preprocessor directive. And what that means is it is going to be run before the program compiles. So what I want to do here is demonstrate how to pull in an outside file. What we're going to do is we're just going to come up here to header files, right click on that, go new. And what I'm going to do is come right here where it says C++ class and click on that. And then it's going to ask me what I want the class name to be. I'm just going to keep this very simple and just leave it as animal. And I'm not going to change anything. And I'm just going to click on finish. That's going to automatically come in here and create all of this stuff for me. This is all licensing stuff, so I'm just going to get rid of it. It doesn't really matter. And I'm going to leave this file exactly as it is. This is the animal.cpp file. And then we can come over here and click on animal.h. Once again, this is all just documentation. It doesn't matter. I'm going to get rid of that. And that brings us to these guys, these preprocessor directives that you have never seen before. What this guy right here does, the if, and def, and then the end if at the very bottom here, this guards against including this header in multiple different files that would make up our program. Because if we did that, that could potentially cause some issues. So that is why we're going to use that, and it's nicely generated for you, so you don't need to worry about it too much. And then this guy that I just highlighted right here, make sure that we read the following lines only one time. And you can see also the constructor for our animal class that we just created inside of here. What I'm also going to do here to demonstrate that this actually works is I'm going to come in and go standard string and name, put that guy right there. And that is the only change I'm going to make to that. And then I'm going to jump over into the main file. Then to include that outside animal class that we just created inside of here, I'm going to go hash symbol and include. And then inside of quotes, I'm going to go animal.h like that. Now what I'm going to be able to do is come down inside of main and create animal objects. So I can just come down here and go animal as if it was right inside of there and spot, oops, spell spot correctly, is equal to, and call the constructor to create that animal object. Then I can go in and go spot, and since name is public, I can assign it directly. So spot like this. And then just to prove that I can go and call that object and print out its newly assigned name. So like this, and I can say something like the animal is named, and then go and call for spot's name. So we'll just go spot dot name and then throw in a new line, of course, and then we can run that. Whoops, and that gave me an error because I didn't define what a string is, so let's bounce back over into that file. And then we can just come in anywhere inside of here before the class and go hash include, and then we're going to go and get string, and then we'll save it, jump back over into main and run it again. And you're going to see this time that animal is named Spot pops up. Okay, so that's a real quick way to include classes or pretty much any outside files directly inside of your code. And now that I demonstrate that, I'm going to show you some other preprocessor directives. Now we're also going to be able to create what are called macro constants, and these are going to be replaced anywhere. Remember, the preprocessor directives run before the program is compiled. So basically what I'm saying here is anywhere where I have pi inside of my code, I want that instead to be replaced with this number right like that. And you don't put semicolons on there or anything. Also, what you can do is create what are called macro functions. And how you do that is you could just do something like area of circle and say that it receives a radius passed into it. And then you're going to use parentheses here. And you can see here I'm going to use pi inside of there just for the heck of it. And then I'm also going to go and calculate the area of a circle. So standard pow and get the radius and 2, and there you go. That is all set up. I'm then going to be able to call these inside of main just like any other function. So I can just come in here and call for this to execute and print out on the screen. So I'll say circle area like this, and then you can call it just like any other function. So circle once again, and 5, and then we can throw in another new line. All right, and I demonstrated how pi works right there, and there we go, and we can run it, and you're going to see that it goes and calculates the area of a circle properly. Okay, so there is another preprocessor directive. Now what I want to talk about are template functions. Now we use templates to create both functions as well as classes that can work with many different types. Now templates differ from function overloading in that instead of having a function that does similar things with different objects, a template, that's how function overloading works. A template instead does the same thing with different objects. So let's come in here and let's create one. So basically, if you want to create one, you're going to say something like template, and then we can say type name, and this is going to represent the different types that are going to be used with our function. So anywhere you see T, that means that that's going to be a changeable data type that's going to be used with our function. You're going to type this every single time. And then let's create this. I'm going to create a template class here in a second. So let's say we want to go times 2 is going to be what this is. It receives a data type that we do not know what it's going to be, so we're going to mark that as T. And then inside of it, it is just going to print out whatever value is passed into it. So we'll go value, and then we will multiply it times 2 is going to be equal to, and then we'll go down to the next line, and then we'll actually do the calculations. So multiply a value passed in times 2, and then we will print out a new line. Okay, so there is our first template function. We're going to create a couple more. And then down inside of main, I'm going to demonstrate that you can use multiple different data types with it. So we can just go times 2 like this. And if we want to use integers, we can just throw an integer inside of there. And if we want to use a double, we can also do that. So times 2, and then we'll throw something inside here like 5.3. There we go, execute, and you can see that it works with both integers as well as doubles seamlessly without any issues. Now we're also going to be able to receive multiple parameters and also, of course, return a value. Once again, we're going to have template and we're going to have our type name defined inside of there. Let's just get rid of this altogether. This time, however, we're going to be returning a value. So we're going to throw T inside of there because we don't know what the data type is going to be. T represents the unknown, and then we go T, and it receives multiple different values. Both of these have to be the same though, because that's how I define them. And then I'm just going to go return and go value plus value 2 and pass that back. While I'm here, why don't I go and create another one of these? So once again, we're going to go template, and we're going to define that we want to use the same value here once again to represent the unknown. And this guy is going to get, let's call it max. It is going to receive an unknown, which is going to be value, an unknown, which is going to be value 2. And then what it's going to do is it's going to return whatever the maximum value is that was passed into it. So we'll go val less than and val 2. And then what we can do is go question mark and val 2 and val. And there's the ternary operator we all know and love. Now what we can do is come down inside of main and execute these guys. So let's come in and output. So what we're going to do here first is go and add 5 plus 4 and get our output from that guy. And then I'm going to call area. Oops, I don't need that. What am I doing? Add. There we go. Add. And then we'll pass in 5 and 4. And I'm sure you can figure out what that does. Not that complicated. And we can go like this. And then we're going to go and do the same exact thing with floats, just to show that that is also going to work. So we'll just go and change this to 5.5, and then we'll change this to 4.6 or something like that. And of course we have to change this, and we have to change that as well. And what else are we going to do? We're going to go and test out max, and I'm also going to show you that you can pass in strings. It doesn't matter. It's very, very flexible, and that's why they are very useful. Okay, so let's go and do something like max of 4 or 8, and that's going to be equal to something. So let's throw that inside of there. Now let's get this all in one line, and then we can just call max and whoops, max, and pass 4 and 8 inside of it, and then throw in a new line, and then let's get a couple copies of that, work with a couple different things. So let's get this again, throw that in there, go that in there. And let's also go, let's show that we can work with characters. So we'll do something like A and A or B anyway. And of course, if it's characters, we're going to put single quotes around these guys. So like this. All right. And we can also work with strings. So we can say something like dog or cat. And then we can do a comparison between those two. This is going to be double quotes. So we'll go dog and cat. And I think that's good. Let's run it. Whoops, what did I do? Oh, I accidentally put uppercase. I got a little confused. All right, let's throw that inside of there. There we go, and run it. And there you can see that we were able to do those comparisons and how they came out. All right, so cool stuff. And now that I demonstrated template functions, I'm now going to take a look at template classes. Now, template classes are classes that can work with different data types, just like template functions work. And what we're going to do here, we'll do something a little bit different. Let's say that we want to define that we may receive parameters with different types. However, they don't have to be different types. How you do that is you would go template and type name, just like we did before. And we're going to go T, and then we're going to define another one. So we'll go type name and U. Okay, now that we have that set up, let's create a class called person. Then I'm going to come in here and go public. And then what we're going to do is we're going to have a height as well as a weight, just to keep it simple. And just know that these might be doubles, they might be floats, they might be integers, they might be whatever. I'm also going to demonstrate static because static is very weird whenever we're using template classes, so I want to cover that as well. So I'm going to create an integer, which is going to be num of people. This confuses some people, so it's a good thing to cover. Let's go and create a constructor as well. Again, we're going to put T, and that's going to be our height. U is going to be our weight. And then inside of here, I can just go height is equal to H, and weight is equal to W. And then we're going to increment num of people inside of here. So every time we create a new person, we'll increment that. And then let's go and create a function that's just going to return some information on our object. Let's call it get data. Makes more sense. There we go. All right, so whenever that's called, what that's going to do is just print out all the information that we know about our little person object. So I'll go height and print that out and then get its height. And then we will also come in and let's say and weight. And then let's go and just put this all in one line, just so that we can hopefully get all our code all in one line, because I know everybody seems to like that. So there we go. Throw a new line inside of there, and we can probably just get this all in one line. There you go. You can see all the code all in one place. All right, so now that we have that all set up, what we're going to have to do with our static that we defined inside of here is we're going to have to say template outside of here and go type name and define T, and then once again type name, and this is going to be U, just like we defined right with this guy up here. Okay, and then what we're going to do is we're going to say int person T and U. It's going to return a integer, and there we go. And then we're going to come down here and go num of people, and that's going to have to be set up for all of your statics. Now what we can do down here inside of main is let's go and create a person, and we're going to go person, and then you're going to have to define what data types are going to be passed inside here by default. If you don't, you're going to get an error. So let's say I wanted to say something like Mike Tyson, and we'll go 5.83 for height and 216 for weight to create that. Then we can come in and go Mike Tyson once again, and we can call get data, and there we go, and we can print that out on the screen and we can run it, and you can see that it pops up right over here. I can move this over. All right, so height and weight prints out on the screen. Okay, good stuff. Now let's go and demonstrate how num of people is going to work. To access static values inside of here, we're going to have to go see out like this, and then a number. This is going to throw you because it's not going to work the way that you think it should work. So then we can go number of people, and you might think that you need to call the class, but you don't. You actually have to use an object to access the static type. So, and that is how that works. and then we can go and execute it, and I can run it to show you that it works, even though it doesn't, you wouldn't think it should work. Okay, so that's how that works. So that is template classes, as well as how statics work with template classes. And now I'm going to talk about iterators. So basically, iterators are going to be used to point at container memory locations, and there's a whole bunch of different containers. A vector is an example of one. So let's go and create that. And in the next part of the tutorial, I'm going to cover some other different containers and have a lot more problems in it. So what I want to do here is I want to go and create, let's go nums2 is equal to, and 1, 2, and 3, and 4. And let's just throw that information inside of there. Now what I want to do is I want to define an iterator as the same type with what I'm working with, the container that I'm working with. So I'm going to go standard vector, of course, and I'm going to say int. And that is so that the iterator knows how much to move forward whenever it's trying to traverse, or backwards whenever it's trying to traverse a container. So there it is, iterator, and I'll just call this ITR just for short. Now what I'm going to be able to do is refer to the vector's beginning and ending like we talked about before. So I'm going to go for, and I'm going to get my iterator, and I'm going to have it equal to whatever nums2 is. So nums2, and I want to start at the beginning of it. And we've already seen this guy before. And then what I can do is come in and say that I want to continue cycling, as long as the iterator is less than nums2. And then we'll go end. Again, we've seen that guy before. And then I can go iterator and increment my iterator. And then, of course, we can just come in here and just print this all out just to show that we were able to get it. However, I said this is a pointer, so what we're going to have to do is put the star symbol inside of there if we want to actually be able to get our value and print that out on the screen. And we can go like this and like this and like this, and you can see it prints out 1, 2, 3, 4, all the different values in the vector. But that's not the end of iterators. You can do a whole bunch of other different things. You're also going to be able to increment a set number of spaces. So let's come in and let's go vector again and int, and of course this works with non-integer containers as well. So we can go iterator again, and let's just create a brand new iterator, and let's set its initial place to nums2 and begin, and there we go. Now what we're going to be able to do is, let's say we wanted to advance 2 spaces. We're going to say advance, and then we can go iterator 2 once again, and 2 spaces we want to jump forward. And now we can come in and output that new value that is assigned to that location in memory. So iterator 2, and we can go and get that value. And there we go. And whoops, advance. I spelled advance wrong. You're supposed to tell me things like that, internet. There we go. Advance. And there we go. And you can see that it went and jumped from this space right here. That's the first place to 2 forwards, so that's 2, 3, and that's the reason why I printed out 3. But that's not the end of iterators. Let's do some more. You're also going to be able to use next, which works like advance, but it returns an iterator instead. So let's just use auto here just to keep this simple. So I'm going to create another iterator is equal to, and I'm going to say next, and I'll go iterator 2, and then 1 position. 1 forward is what it's going to be returning, and then what I can do is just output that also on the screen, that new location, and you can go and take a wild guess at what you think the value is going to pop out. And if you guessed 4, well, you are indeed right. All right, and another one. Let's talk about previous. Previous is going to move a set number of indexes and backwards or towards the front of the container. So let's just go, let's just copy this all together, and there we go. And save ourselves even more time. And let's go and give this the value of iterator 4, since that's what it is. Let's leave this be the way it is, but let's change this to previous, which is shortened to PREV, and leave that be iterator 2 once again, and leave that be 1 just like we did before. And let's change this to 4 and save it, and see if you can guess what the value is going to be. And if you guessed 2, you indeed were correct. And to finish this all off, what I'm also going to show you how to do is how we can insert a container into another container at a set location. So we're going to come in and let's go and create another vector. So standard vector, and this is going to be an integer as well. And let's just call this nums3. And let's give this a value of 1 and 4 and 5 and 6. That works out pretty good. Okay, so we got that set up. And let's go and create another. And I'm going to insert one vector into the other vector. All right, so add a set index. Change this to 4, and then let's change this to 2 and 3, which are the values that are missing from there, or what we would assume is missing. Then what we're going to do is go auto and have it just automatically figure out whatever the data type for that is. And we'll say nums and 3 and begin, and to get that starting location. Then what we can do is we can come in and use advance. We could also use next. Try that for homework if you'd like. So let's say advance and iterator 5, and let's say we want to go one space ahead from the beginning. Then what we're going to be able to do is come in and say copy, and we're going to go nums to 4. Oops, nums 4 and begin, and that is this guy. So what we want to do is we want to take this guy and put it right there. So we're going to get our beginning location for that guy, and then also we're going to get our ending location for that as well. So we'll go nums 4 and end. So we're saying we want to copy everything that is in there into what we're going to define here. So we'll say inserter, and this is going to be where we want to insert that vector. So we'll say nums 3, and then we'll say we'll use the iterator to define the exact location where it goes. And then after we have that in, we can use 4 and int and our and symbol here to get our actual value that is stored there. We'll say once again nums 3, just because that's where we just put all of our new vector, and we can cycle through the whole entire thing and print it out on the screen just to show that indeed it did work. And if we run it, you can see that indeed it did. 1, 2, 3, 4, 5, 6. All right, so there you go, guys. Whole bunch of things you guys have been asking me about, all crammed into one tutorial like always. And like always, please leave your questions and comments below. Otherwise, till next time.